Welcome back, guys. In this video, we'll be looking at trig identities. Believe all the identities you need to know for O level will be treated in this very video. Now, let's start by introducing what we all know as a right-angled triangle. Right-angled triangle. Now, if I name here to be A, name here to be B, and name here to be C, now let's call this guy theta. We'll be working with theta, and let's call this guy let's say alpha. So this is theta and this is alpha. Emphasis is on theta. We are going to use theta to generate a lot of trig identities that might end up covering all the part of this board. Now, remember our sine theta, as we all know, is opposite over hypotenuse. In this case, we call it A over C. Our cos theta, adjacent over hypotenuse, so we call that B over C. And lastly, we have our tan theta, which is opposite over adjacent, which we call A over B. Now let's look at the inverse. The inverse of these guys. 1 over sine theta is referred to as cosec theta. So that's one trig identity you need to know. 1 over cos theta is referred to as sec theta. And lastly, 1 over tan theta is referred to as cot theta. 1 over sine is cosec, 1 over cos is sec, and 1 over tan theta is cot. Now that we are done with that, now let's talk about sine and cos. Let's talk about sine and cos. So if this is theta, alpha here, alpha in this case can be referred to as 90 minus theta. And why is alpha 90 minus theta? Alpha is 90 minus theta because what you have here is what? 90 degrees. So 90 plus theta plus alpha should be equal to 180. So let's do the math here. 90 plus theta plus alpha is equal to 180 degrees. So therefore, alpha will be equal to 180 minus 90 minus theta. 180 minus 90 is 90 degrees. So this is alpha is equal to 90 minus theta. So alpha can also be written as 90 minus theta. So let's work with 90 minus theta. You will see something very beautiful when you work with 90 minus theta. So what is sine 90 minus theta? Sine 90 minus theta. This becomes our opposite and this becomes our hypotenuse. So sine 90 minus theta will be equal to B over C. Cos 90 minus theta will be equal to, now this is our adjacent, A over C. And lastly, tan 90 minus theta is equal to, in this case, tan 90 minus theta will be B over A. B over A. Now let's start comparing. Remember, this remains A, B, and C. What is A over C? A over C is what? Cos. A over C is cos. So I can boldly write here. That, okay, I think I should start from here. I can boldly write here sine theta, which is A over C. This is also A over C, is equal to cos 90 minus theta. So that is a relationship that we've built already. Now let's move on to cos theta. Cos theta is B over C. And where do I have B over C here? This is B over C. Cos theta is equal to sine 90 minus theta. So that's one, or those are one of the trig identities that I should take note of. So this simply means sine 45 will be equal to cos 90 minus 45. So sine 45 is equal to cos 45. And we all know that that is root 2 over 2. Similar fashion, sine 60 should be cos 90 minus 60. So sine 60 should be cos 30. Sine 60 is root 3 over 2. Cos 30 is root 3 over 2. So you can see where that came from. Now this very relationship also holds for cosec, secant, as the case may be. Now let's bring out what cosec is, what sec is, and what cot is using A, B, and C. Now we just said sine theta is A over C, so cosec theta is 1 over sine theta. So I can write here cosec theta. Let me work with blue. I can write here cosec theta is equal to 1 over sin theta, and that will be what? C over A. Sec theta is 1 over cos, and that will be C over B. And lastly, you have your cot theta, which is 1 over tan, and that should be B over A. Similar fashion, let's do cosec, sec, and cot for 90 minus theta. So I can say cosec 90 minus theta is simply cosec is 1 over sine. So 1 over sine 90 minus theta, which is sine 90 minus theta is B over C. So 1 over sine 90 minus theta should be C over B. Then you have sec 90 minus theta. In this case, that is 1 over cos 90 minus theta, which is C over A. And lastly, you have your cot 90 minus theta. In this case, B over A, so that should give me A over B. Cot 90 minus theta should be A over B. Now, let's look at the relationship that we can build from here. Now, starting with sec theta. So, my sec theta is equal to C over B. Where can I find C over B here? This guy. So, this is equal to cosec 90 minus theta. Then moving on to cosec theta is C over A. So where do I have C over A? Sec 90 minus theta. So cosec theta is equal to sec 90 minus theta. Lastly, you have your cot theta. Cot theta is equal to B over A, and that is something as tan 90 minus theta. So this is equal to tan 90 minus theta. Then you have your tan theta. We've not worked with tan theta, so let's work with tan theta. Now tan theta is equal to A over B, and that will give me cot 90 minus theta. So the relationship that holds between sine and cos hold for sec and cosec, also hold for cot and tan. So that's one of the trig identities. Now let's still play with this guy using Pythagoras theorem. Using Pythagoras theorem from here, you agree with me that A squared plus B squared is equal to C squared. Now let's divide through by C squared. I have not changed anything. So dividing through by C squared. This will give me A squared over C squared plus B squared over C squared is equal to C squared over C squared, which is 1. So A squared over C squared, indices can be written as A over C all squared plus B over C all squared is equal to 1. What is A over C? Sin theta. I can say sin theta all squared plus what is B over C? Cos theta. Cos theta all squared is equal to 1. Now, sin theta all squared can be written as sin squared theta. So this is sin squared theta plus cos squared theta is equal to 1. That's another trig identity that you need to know. Sin squared theta plus cos squared theta is equal to 1. Now, from this, we'll get the remaining trig identity that are needed in this video. Now, let's repeat that here. Sin squared theta plus cos squared theta is equal to 1. Now let's divide through by sin squared theta. So this will give me sin squared theta over sin squared theta plus cos squared theta over sin squared theta is equal to 1 over sin squared theta. This will give me 1 plus cos over sine. Cos over sine, okay, I didn't mention that, so let's do that now. So I forgot some trig identity. Now note that your tan theta is equal to sin theta over cos theta. Tan theta is equal to sin theta over cos theta. So I'll prove that now. What is sin theta here? Sin theta here is A over C all over cos theta here is what? B over C. Now let's cancel out. C cancel C. I'm left with what? A over B. And what is A over B? Tan theta. So sin theta over cos theta is tan theta. Similar fashion, cot theta is equal to cos theta all over sine theta. So that's another trig identity that you need to know. So cos over sine is cot. So this should give me 1 plus cot square theta, because we're having a square here, is equal to, what is 1 over sine? 1 over sine is cosec squared theta. So that's another trig identity that you need to know. Now bring this guy down here. Sine squared theta plus cos squared theta is equal to 1. Let's divide through by cos squared theta. Divide through by cos squared theta. So this should give me sine squared theta over cos squared theta plus cos squared theta over cos squared theta is equal to 1 over cos squared theta. Sine over cos is tan. So this is a tan squared theta plus cos over cos is 1, and 1 over cos is sec squared theta. So what are the trig identities that you should take note from this video? So these are the trig identities you should take note. Number 1, 1 over sine theta is equal to cosec theta. 1 over cos is sec, and 1 over tan is cot. Similarly, tan is sine over cos. Then sine theta is cos 90 minus theta. Cos theta is sine 90 minus theta. You should also take note that cot theta is cos over sine theta. So I'm marking what you should take note of. Sec theta is cosec 90 minus theta. Okay, let me make use of black here. Cosec theta is sec 90 minus theta. Cot theta is tan 90 minus theta. And tan theta is cot 90 minus theta. Then in similar fashion, you take note that sine squared theta plus cos squared theta is always equal to 1. Take note that 1 plus cot squared theta. 1 plus cos squared theta is equal to cosec squared theta. And lastly, tan squared theta plus 1 is equal to sec squared theta. So let's count the trig identities that you should take note of. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have 14 trig identities that you should take note of. And once you know these things, I believe you solved more than half of your problem when it comes to simplifying trigonometrical functions. Now, next video, we'll be looking at compound angles. That's where you have something like tan A plus B, cos A plus B, sin A plus B, as the case may be. So we'll try as much as possible to prove the formula so that you can understand it better. Thanks for watching this video. If you like this video, if you enjoyed the video, kindly use the like button, and don't hesitate to subscribe if you are yet to do so.